Hello, dear colleagues. Let's continue our lectures about IT technologies and e-health. My name is Konstantin Koshichkin. I am Associate Professor of Sechenov University Digital Health Institute, and today we'll talk about intelligent medical decision systems. And in major part of today's lecture, we will talk about artificial intelligence and how it's being implemented in healthcare and how decision support systems are using this technology for different process automation and other areas. I will repeat the definition for artificial intelligence. It's a complex of technological solutions that allow to simulate cognitive functions of a human person, and obtain results performing specific tasks that are comparable with results provided by humans. We should say that there are two types of artificial intelligence. It's strong AI and narrow AI or weak AI. In general terms, strong AI is something in fiction movie. It's a universal system to solve any problem, as similar with human, and it's quite a theoretical concept nowadays. And on practice, we are working with narrow or weak AI. It's systems which are aimed to solve a specific task or specific problem, and they're highly specialized systems, and they're perfectly working in current situation, and we're meeting these solutions, I guess, every day right now. Talking about artificial intelligence, there were several very important discoveries in latest years connected with this technology. First of all, I guess this boom of artificial intelligence technology started with IBM Deep Blue, when this system beat world chess champion, and then there were several inventions related to self-driving cars, automated translations, other types of games when humans had a competition with computer, and computers showed good results. Other major discoveries were ImageNet solving increase when system identify images, and quality of this identification progressed in a huge amount in the last decade. And major corporations invest a huge amount of money in artificial intelligence. It's OpenAI, DeepMind from Google, and lots of other systems. We need to distinguish different terms in this area from one another. Starting with artificial intelligence, it's a wide area of solutions. Mostly it will be computer programs, but in early years it was some devices without modern programs in them. And talking about machine learning, it's a subsection of artificial intelligence, and this area concentrate on mathematical methods, how to solve different problems in implementation of artificial intelligence with mathematical algorithms. And artificial neural networks, it's a simplified model of biological neural networks, and we will cover this area in more details a bit later. So the topic of artificial intelligence started about a half a century ago, even later, and even earlier, I mean, and it was at the beginning I tried to create a human-like robots and something like that, but nowadays we are talking more about some technical solutions under the hood of the computer program running somewhere in the cloud. So what we mean in this area with the technology is quite different from year to year. As an example of progress in this area, it's easy to show that nowadays algorithms are being trained on huge data sets. For example, ImageNet contain 15 million tagged images. On them, humans already named what you can find on this image, and you can train a neural network with this identification descriptions. And currently Google able to find frames with cats on video stream in YouTube, for example. Why this artificial intelligence boom is happening right now? There are three main criteria why this is happening, and first of all, it will be an accumulation of huge amounts of data in digital form, so we're able to aim our artificial intelligence system on this dataset to train it. And also we have a huge progress in creating different architectures for such solutions. We have deep neural networks, and they provide results which we receive from the systems are hugely better than what we had in previous architectures. And of course, currently we have computation power which is incomparable with our previous possibilities, and it will trigger such solutions anyway. So what's intelligent information system? It's a system for automated information and knowledge processing, or a complex of software, linguistic, and logical mathematical tools for implementation of some kind of task, supporting human activity and supporting humans in search for information in the mode of advanced dialogue in natural language. What are the main characteristics of intelligent information systems? It will be ability to communicate with users, with its human counterpart, and ability to solve complex, poorly formalized tasks. And next one will be ability to self-study or self-improve and adapt to new requirements and new tasks. Neural networks are parallel computing devices consisting of many interacting simple processors. Each processor in such a network deals with signals in periodically received signals and periodically sends to other nodes of this network. In expert systems based on precedents or analogies, the knowledge base contains descriptions of generalized situations, but of the actual situations or precedents. The search of the solution to the problem in expert systems based on precedents is reduced to a search by analogy, and so we are able to gather knowledge from previous experience. There are several methods which we can use. In some cases, we need to have an exact computer algorithm which could be proven in which condition we will receive, which result that we will have in which conditions. For example, this hard computing is being used in financial transactions processing and other areas when we need to have exact data. And soft computing is based on statistical methods, and we are talking about different levels of certainty in our results. So it's impossible to say 100% that something detected by neural network is true, because it will be always based on some statistical approach under the hood. And there are hybrid systems combining methods from both parts of this methodology. So expert systems are combining artificial intelligence and formalizing knowledge gathered from experts to provide additional insights or consultations for less qualified specialists. Expert systems are designed to solve problems on the basis of accumulated knowledge and reflect previous decisions made by experts in this area with the means of automation. In healthcare, we have a long history of such systems being designed and introduced, and it's not something novel, and currently we are talking only about the technology under the hood of these systems. First generation of the systems from the late 60s to 90s of previous century were based mostly on the knowledge of one expert who were using this system, and there was impossible to organize data exchange between the systems in different facilities, and representation models are very focused on one target, and there was no training in the systems. Novel systems are based on knowledge exchange between different experts. There are tools for this knowledge processing based, for example, on neural networks or decision trees or other methods. And these systems currently have dynamic knowledge base, so they're gathering additional data to base their decisions on, and it allows the systems to develop. Why we need expert systems to be used? In some cases, we have conditions when humans are, when it's dangerous to operate for humans, or no one is available, and in other cases, we have problems where we do not have an algorithm already known to experts, and we can implement expert system to gather lots of data, analyze it, and provide new insights which were previously unavailable. The basis of any expert system is a body of knowledge structured to simplify the decision-making process. A confidence factor is a number that denotes the probability or degree of certainty with which a given fact or rule can be considered reliable or fair. What is the structure of expert system? The selected knowledge about the subject area is called knowledge base. A knowledge base contains facts, it will be data, and rules, or the representation of knowledge, that use these facts as a basis for decision making. The mechanism of logical interference is a part of expert systems, knowledge base system. In the vast majority of knowledge-based systems, the interface mechanism is a small program, and there are two components in this program: an interpreter that determines how to apply rules to infer new knowledge base, and information store, and all data management processes, and dispatcher who establishes the procedure of application of these rules in the system. So we have the database. It will be our working memory. We'll have knowledge acquisition process, gathering additional data into the system. The presence of an explanation, and it will be our logic to process this data, and the dialogue component, which will be aimed at communications with users and other partners. And these partners could be external systems or other world entities to gather data, to provide data. And of course, the systems will have to work with some external interfaces to gather data and to provide data. How to understand that we need expert system in a certain area to be developed? Of course, we need to calculate if this cost of this problem solving will cover expenses for development of such a systems. Other situation could be associated with a lack of human experience in certain area, or lack of human experts at all. Of course, it could be applied only if this problem is possible to solve in symbolic logic in terms of mathematics, and it's not some area of opinion of a person. It should be calculatable. The problem area is well structured and doesn't require common sense reasoning, because for common sense we'll need to have a strong AI, and we don't have it nowadays. I guess the most common error is when we're trying to apply artificial intelligence in situations when traditional computation methods are quite enough, and I guess it's a question of fashion, and everybody nowadays want to be a specialist in artificial intelligence, and no one want to be just a statistics expert. It's very important that our experts have a common opinion on certain questions in the problem area, because if we have each expert with his own opinion on this matter, it's impossible to implement decision-making system automation. And of course, this problem should have some dimensions and boundaries, because we need to limit the system to some area. What will be the steps to develop expert system? Of course, it will start with demo prototype, implementing several rules. Next, we'll have research prototype with hundreds of rules in it. Next, we'll have usable prototype, which we could provide for users outside of our development team. Next will be industrial design, when we have a solution which could be implemented on some facility or organization. And the next step will be we'll have commercialization of the solution, so it could be provided for the common public. Talking about neural networks, it's very interesting that design of this mathematical logic was taken from biology and is based on human or other living things, neurons, and what is the structure of neurons. They have dendrites which receive signals from other neurons, and they have axons providing connections to the next neuron, and the body of neuron will accumulate all data from dendrites and provide a decision if potential received is enough to send a signal for the next neurons through its axon, and this decision making is replaced with mathematical function, and this signal propagation replaced with data, and it's data being sent from one node of the network to the next one. So we have a network in which each dot represents a neuron gathering data from previous nodes or neurons and sending to the next level of the network. And as a result, we have a decision if our input data meet all the requirements of this network to provide a certain result. So our artificial neural network is an analogy of brain tissue connecting neurons with one with another, and processing input data to the output. This works to create mathematical models of human brain. Were quite a huge amount of time ago, and currently we are still using these models which were created by the early scientists in this area. Every neuron, both artificial and natural, is characterized by transformation function, neuron execution, or excitation function. Neurons in the network may have the same or different excitation functions. The signals that come to the input are not equal. Information from one source may be important for this neuron's activation in different areas of the network. There are a lot of ways how we can classify our neural networks. By topology, it will be fully connected when each neuron is connected to other neurons. Multilayered networks, when we have neurons structured in layers, and these layers connected with one another, but these neurons in the layer are not connected horizontally, better to say vertically, with the same level neurons. On the organization of training, we'll have neural networks which will be trained with a teacher and without a teacher, by types of structure. For example, with different types of activation functions, by type of connection. There will be direct propagation when signal come only in one direction from entry layers of neural network to the output layers, and no feedback is available. And recurrent neural networks, when we have connections with back propagation of the signal. By signal type, we will have binary to process digital data, and analog to process continuous data streams. So basic artificial neural artificial neuron will have only one type of interaction. It could be activated or not with input signal. And to decide if it will be activated or not, we will have an activation functions and coefficients which could be adjusted during the training. And by this coefficient, we will have a way how this neural network could be trained to detect a certain type of data. Talking about threshold functions, we'll have different types of it, and they could be linear or non-linear functions, and different types of activation will provide different results in different conditions. So a neural network is a collection of artificial neurons organized in a certain way. For example, it could be layers, and the output of one neuron is connected to the input of another neuron. To solve a specific problem with help of neural network, you need to choose type of connections for neurons, determine the type of activation functions, and select weights for coefficients in these activation functions. In early years, there were attempts to create a analog system to process data in this way, and it was Rosenblatt machine, for example, and it was working by mechanical connection from one node to another, and these nodes were based on light bulbs, and these calculations were in analog form. How the training process is being done? The system is presented with a reference image. If the recognition results are the same as specified, the weight coefficients are not changed. If the network incorrectly recognizes the result, the weight coefficients are given an increment in the direction of improving the quality of recognition. Perceptron has limited capabilities because there are not always such a combination of weights at which a given set of images will be recognized correctly. The reason is that a single layer perceptron implements a linear divided surface of the standard space, as a result of which incorrect recognition can occur. In single layer networks, signals from input layer are directly fed to the output layer. It performs the necessary calculations, the result of which are immediately fed to the output. A single layer neural network is a network in which signals from the input layer so we have the response of the system without additional layers. There was one more type of networks which were called Hopfield model, in which there were connections on the same layers of the neurons, and if one neuron will be activated, if certain amount of neurons will be activated simultaneously, they will be connected, and for example, it could be used for associative memory, but currently these networks are rarely being used. Another interesting type of networks were coherent networks, and these networks were self-organizing. This means that connections between neurons were creating during the work of the network and are not predetermined before on the architecture stage. And nowadays, most interesting architecture for artificial networks are multi-layer networks. In these networks, we have data signal transmission from one layer to the next one, and for example, this architecture enable us to have certain neurons to be activated on the certain features of data, and different layers of this system will be responsible for different level of details in the detection, for example. Most basic multi-layer networks are feed-forward networks when we have signal transmission in only one direction, and these types of system are being widely used in forecasting, clustering, recognition, and other. In loopback networks, we have connections not only from input to the output, but also there will be connections between output to input, so signal will be able to have several cycles of processing in this network. Training of a neural network is a search for such a set of weights in which the input signal, after passing through the network, is converted into the output that we need. So we need to have a training set of data which we already know what this data is and what result we are going to receive from this input data. Testing set is a finite set of input signals that assess the quality of the network. Training by the backpropagation algorithm involves two passes through all layers of the network, forward and reverse. In a direct pass, the input vector is fed to the input layer of the network and then propagates through the network from layer to layer. As a result, a set of output signal is generated, which is an actual reaction of the network to this input image. During the direct passage, all synaptic weights of the network are fixed. During the return pass, all synaptic weights are adjusted according to the error correction rule. The actual output of the network is subtracted from the desired one, resulting in an actual error signal. This signal subsequently propagates through the network in the opposite direction of the synaptic connection, and so we have this is the way how this network could adjust its weights to provide better results automatically. From the mathematical side of the question, we could present each network as a series of equations when we have weights of each neuron combined together and result in a certain summation function to make a decision on activation. And this function could be provided by different types of functions. It could be jump function, and it will be just activation when the data will reach a certain amount or level. And most commonly used currently will be a sigmoid, and on using this function we have more precise activation depending on the level of inbound signal. Another function will be hyperbolic tangent. And now let's talk about teaching with a teacher. It will be called supervised learning. It's a type of neural networking in which its weights are changed so that the network's answers are minimally different from the ready-made correct answers. So we were talking about this technique previously, and it is based on correction of weights in different directions to achieve the best result in processing of this network. And based on error level, we are able to adjust weights in this neural network. Next type of training is unsupervised learning, and in this case we do not have correct answers for this network, and it will operate gathering insights from the data itself. For example, it could be used to classify some data and provide groups of this data most similar to each other. There are two major problems in neural network trainings. It is undertrained networks and retrained networks. In first case, we will have processing of the network with results not specific enough for good data in output, and if this training was too specific to the input data, this network will not be able to work in conditions different from training data. So we need a balance between these two levels of training, so this network will be able to operate on general data, but results of the system will be good enough for us to use it on practice. One of the implementation areas of neural network will be pattern recognition, and we are not talking only about patterns in images. It could be all types of patterns in different types of data. But of course, mainly it is being used in image recognition, and there is a lot of ways how this data could be used. And the most important discovery in image recognition currently is convolutional neural networks. In these networks, we are making small samples from images and working with each sample independently, and after that we will gather data from all samples, providing a decision made by this network. For example, these networks are being used for object detection, and for example, self-driving cars are detecting objects on the road by such a convolutional neural network, gathering some parts of data and receiving results that this part of image is similar with previously gathered data in on the training stage of development, and this system able to name what is the exact area of received image where this object is located, and it is very important function of such networks. And first of all, we will need to have a huge amount of data with predetermined objects, and these objects should be named. So based on this data, this network will be trained, and after that it will be able to provide useful results. Why we need multi-layer architecture in this area of implementation of neural networks? We have feature detection in input data, and we need to have neurons which are trained on exact feature, and only when we're summarizing multiple features from a certain part of the image, we will be able to say that this image is some kind of object. This technique could be used in multiple areas, for example, image recognition, handwritten text processing, sounds processing. What else? Of course, it could be used for image classification, anomaly detection in data, and of course, there are a lot of implementations for such solutions in healthcare. And different types of tasks require different architecture of the network. There could be a combination of different types of layers. They could be recursive networks, long-term, short-term memory networks, shallow networks, just groups of neurons, and a combination of these layer architectures will provide a suitable result for our task. There are ways how we can combine training techniques with marked datasets and unmarked datasets, and the neural network will be able to extract data from these datasets and adjust it with unmarked data. So the results of this network will be more less specific to the training dataset and more general. Of course, mainly to create a training dataset, you will need human labor, and in most of the cases, this data types naming will be processed manually. If we're trying to implement unsupervised learning, the training samples do not have labels on them, and the neural network will try to identify patterns in the data and extract useful features from it. And in this case, the most common result will be clustering of the information. The algorithm will select similar data and find common features in it and group the results in a certain way. So the major ways of neural networks use will be pattern recognition and classification, forecasting, to create some timelines, for example, in future period, and it will be clustering to divide one object from another. For example, in healthcare, it could be a scan with a malignant tumor and a clear scan. Why I said that convolutional neural networks are the most efficient way how images could be recognized, because in general we have multiple objects on the image, and there could be multiple features, and convolutional neural network will operate with a frame of data from this image, and these frames could vary in size and find features relevant to the part of these images and image and ignore other features. And in this case, it enables us to find specific object on the image. So this type of network is being used most common to recognize certain information in photos, videos, to process natural language, and as a part of recommendation systems. So on this screen we can see a deep neural network and its architecture. And in this architecture we have image processing network for ImageNet database, and there are several layers in this network of different type. Some of them will provide convolutions, some will detect features and summarize data from previous layers, and as a result we will have a feature mask which will allow us to identify object. Conventional neural networks do not scale well for larger images, and they are good to detect data from small images. For example, digits recognition. It's a simple task when we have a dataset of digits, and it could be easily identified by conventional neural network. But if we have a huge image with a lot of data, this neural network will not be able to find a digit on it. But convolutional neural network will be able to find the window with features related to this digit, and it will be identified. Also, convolutional neural networks work not with two-dimension of data in images, but represent data in 3 dimensions, and making this 3-dimension data set enable us to use tensors and processing based on depth of data, but not only width and height. So processing data in this network will extract data from previous layer of the network, and results of this layer will be the same data but in another dimensions with another parameters. And this feature is quite useful to detect data from images. For example, when we're talking about images, we have at least 3 dimensions in colors. It will be red, green, blue, and it could be used as data dimensions to create such a 3D structure to be analyzed in neural network. I will not go deep in description of structure of such a network. I will just name that there will be layers of convolutional layers. It will be fully connected layers, ReLU activation functions, subsampling layers to extract parts of data. And combination of these types of layers will provide us with a deep neural network, and loading data in this deep neural network will enable us to detect objects on the image. For example, it could be used in handwriting recognition, and in a simplified way, it is a very easy task. For example, currently we could have a neuron for each pixel of data, and if this pixel is black, the result of this neuron will be 1. If it is white, it will be 0, and we can easily see a pattern of zeros and ones on this slide, and loading this data into the network will enable us to provide results in numbers detection. But when we're talking about handwriting recognition, there will be a huge problem, because different people write different digits not in the same way, and we will need to have much more level of details in this network, but it is also easily to be solved, and this network will provide result with a certain level of certainty that this number is 5 but not 3 or something like that. For activation, we could use sigmoid function, and training for this task could be done with NIST database, which is publicly available for neural network training. It consists of multiple samples of handwritten digits in different types, and it's a common training task to train the networks. There are two ways which systems are being expected for us to create. One type of systems are based on the same level of data processing as for humans, and these systems are not expected to provide better results. So we need just to have the same results as humans are able to provide. For example, it could be speech recognition and speech generation solutions. And another type of systems are aimed to detect features which humans are unable to detect. So the quality of work in such systems will be aimed to improve experience for humans, for detect in deeper details unvisible, which are not visible for humans, and which could be understood by neural networks. So we have two ways to implement them. For example, pattern recognition in medicine could improve human performance, not only by providing additional spare hands for our doctors, but also to go deeper in image data and recognize features which are not visible for humans. So in some cases, results of such systems will be higher than results from humans. So where in medicine we could implement pattern recognition technology? For example, in differential diagnostics for many group of disease, similar symptoms will be in place, but introduction of artificial intelligence will enable us to provide diagnostics with higher accuracy by operating all available expert knowledge in the system, but not only one person expert knowledge, and reduce personal biases of the doctor. Next one will be prognosis of complications in treatment for particular treatment regimen. So it will be a personalized treatment for a person, and this system will operate on personal data from each patient and determine what will be the best way of this individual treatment. Next one will be prognosis of long-term treatment results based on previously made treatments and gathering personal data of this patient and what will be prescribed to him. And we are able to use these solutions to identify people or groups of people at high risk and provide personal recommendations how to optimize their lifestyle habits and to reduce risk to minimum, and what will be, for example, life expectancy for them if they will follow these recommendations. Also, these methods could be used for drugs prescription and to optimize dosages, optimize level of concentration of the active substance in bloodstream, and to perform different clinical studies and to find the best molecules to be introduced and so on. And of course, to create such a system, we will need to load a huge databanks of information into the system. And here we are talking about medical records and big data processing and so on. In healthcare, there are a lot of related questions. For example, how to gather this data, how to process personal data, and neural network processing, it's a small part of this. Let's try to compare neural networks with brains of other living things. And for example, in Drosophila fly, we will have 100,000 neurons and connections, and the number of these neurons will increase with the complexity of a living thing, and in some cases not all these neurons are being in use, so they are reserved for additional training and to create additional connections. And according to the current prognosis, we will be able to create artificial neural networks with a number of neurons similar with humans not sooner than in 2050s. But currently we have a lot of implementation of AI in our everyday life. For example, it will be face recognition in our mobile phones. There is tools to recognize images, to calculate calories in our diet, and so on and so on. I will name a few most interesting neural networks architectures. And to start, it will be a LINET. It was first successful implementation of convolutional neural networks designed by Jan LeCun in 1990. It was used to read zip codes, for example. Next one will be AlexNet. It was a image recognition network also, and all these networks are based on convolutional neural networks. GoogleNet also provides such a solution, and the latest one was Inception version 4. And another one is ResNet, so they are quite similar in their aim, but each of these networks took a lot of work and a lot of training hours to be able to operate. And as a result, we have ability to identify different objects on such a complicated images. And in our common life, it could be used not only for medical images processing, but also for lots of other tasks, for security reasons, for data protection, and so on. And talking about radiology, we have pneumonia detection, and this technology was highly developed during coronavirus epidemic, and it is currently being used to process data. So this technology enables us to detect images with affected areas and from images with a normal view. And in the real world, we have this neural networks inside self-driving cars, robots, drones, mobile phones, and so on. So I believe currently we will soon be in a situation when most of the programs will use some type of neural networks under the hood, and it will be provided by different ways to share these networks with general public by cloud providers, for example, by Google, Amazon, and so on. For example, it could be used in problems with small and medium complexity to solve equations, display windows of the programs on the screen in useful places, in simple forecasting, error rate calculation, approximation of solutions, pattern recognition, speech recognition, complex forecasting, and so on. Today I will not cover machine learning techniques. I will just name that similar tasks could be solved by machine learning without neural networks, or for example with mathematical methods for clustering, regression, classification, and of course, it's impossible to classify images without neural networks, because we need to detect features from them, and it is a way how to manage with complex problems, which is impossible to process with a simple statistic methods. And in general, machine learning will be related to hard computing and exact results, and neural networks will be connected with soft computing and approximation of functions where it's impossible for us to calculate the exact results. For example, it could be used in forecasting when we need to operate with a huge amount of data, in process optimization, and in different management systems. In some cases, it could be used in technical parts for memory optimization, usage optimization, and so on. Also, there are implementations in management systems. And of course, we're developing different types of solutions based on this technology. It will be computer vision, natural language processing, recommendation systems, decision support systems, speech recognition and generation. It's widely used in financial industry, agriculture, healthcare, and so on. In finance, there are a lot of implementations of automated trading platforms which are based on features gathered from previous data, from stock exchange, from news, from weather forecasts, for example, and so on. In some cases, there are attempts to implement AI-based systems to replace human operators in some activities, and it will allow to reduce burden for commercial organizations to operate. For example, it could be used to optimize storages in sales. It could be used in recommendation systems to provide advertising, to provide additional insights, what this person will buy, or something related to this area of activities. And natural level language processing could be used in chatbots to communicate, to replace first line of technical support, and most of banks have this technology implemented for fast communication and gathering questions, and in many cases answers for these questions could be provided automatically, reducing load for humans in support team. In industry, such technologies could be used to control complicated machinery and to find some deviations from normal work, to identify dysfunctions, and to recommend some check to be done on a certain machinery on the industry plant. In pharmaceuticals, for example, it could be used to optimize process of synthesis of chemical compounds, and to reduce costs for this manufacturing. In transportation systems, of course, it will be implementation of unmanned vehicles, self-driving cars, but also there are a lot of problems in the area of transport streams management, and in many cases artificial intelligence will be able to provide the best better results in these areas than humans. There are a lot of implementations in agriculture by analyzing images of crops, by planning of production cycles, and other areas. For example, optimization of planting time. In power engineering, it will be optimization of repairs, optimization of control, identification on access to the networks. Even in entertainment and arts, there are attempts to implement such technologies, for example, to process images to improve quality of image, and currently there are different startups in area of old video records processing and improving its appearance by neural networks. One of the most important wins for artificial intelligence was in a game of Go, and it was AlphaGo, which bet the world champion in this game. There are a lot of ways to analyze video for surveillance and to detect some cases of access to the restricted areas, for example, and to save people in complicated situations, and for example, to find a person falling on a video and sending an emergency team to this person. Also, we have different ways to implement in security, for example, virus detection. We talk a lot about healthcare already. It will be used to identify abnormalities in images, to identify objects on the image, to highlight areas. So it's image processing, and one of the most famous solution in this area is IBM Watson, and this technology is aimed on different areas of data processing in healthcare, in oncology, for example, and IBM invested a huge amount of finances in development of the system, and currently it is being used for second opinion and to natural text recognition and to image processing in multiple clinics worldwide. In diagnostics for image study, in providing results from images, so it will be able to describe what was presented on the image. Also, it is being used for DNA sequences processing and to determine markers for different diseases, and another approach to find biomarkers in new drugs development. So implementation of this technology hugely reduced price of genome sequencing, and it is available for general public nowadays. Another project is called DeepMind Health, and it's operating on different types of data related to human health, and first of all, it's aimed to determine what makes a person healthy and how health could be adjusted with medical manipulations. MediMatch solution processing medical images, comparing it with a database of previously made images connected to other patients with diagnosis, and it could find insights on these images, providing recommendations for this patient. For example, it could work with scans. Another approach is to automate everyday in doctor work, and for example, to analyze natural language, to process symptoms, and to provide recommendations for patients. Next solution will provide recommendations for patients based on their personal data and knowledge database. For example, it could be diet, exercises, and recommendations for habits, and so on. Also, there are several ways to analyze human behavior for mental health assessment, and it could be used as a help for neurologists to provide better treatment for their patients. In general, all these systems are being considered as additional solutions in healthcare clinics and provide auxiliary processing of medical data previously analyzed by doctors, and as a source of second or third opinion. But in future, of course, such systems will be able to operate independently and provide better results in analyzing X-rays, MRI, ECG, and other types of instrument-based data received from patients, just because these systems will have deeper way to analyze data in the portions of information which is invisible for humans. Speech recognition is also very important because in many cases doctors do not have enough time to enter all the data manually into the database, but they could provide this data by speech, and it will be recognized and recorded into the electronic health record of this patient. And for patients, it's very important because they can share their symptoms and requests with doctors, not only by calling them, but also by entering these records in some client management systems if they are not urgent and they are just asking for recommendations. This process could be automated, and these recommendations could be found in database. So most of these implementations are related to big data analysis and could be operatable only in connection with some kind of cloud or cluster with data to train the system on and to gather all the previously made decisions. And of course, we'll need to connect all the data related to one patient from different systems in one place. So we are getting back to our previous lectures about electronic health records and how it is important to create a process of data processing first of all, and only after that we will be able to train our artificial intelligence solution to provide these insights. And quite simple solution for this will be chatbots. So when we are able to automate communications, and they could be in written or in speech, and having a good knowledge base, it is quite easy to extract data from this knowledge base and provide it to our patients. Currently, we have a robotic surgeon, for example, Da Vinci, and recording actions of doctors using this robot will gather all the required data to automate this process. So having records of huge amount of hours operating with this robotic surgeon will provide us to create an automatic surgeon which will be used independently from doctors. And for example, it could be very useful in conditions where doctors are unavailable, for example, in space and other extreme situations. So on the next lecture, we will start with the mathematical methods to process this data and how it is being used under the hood. Thank you. For today, it's all.